going. 1, 2, 3, 4, 5. Keep going. 6, 7, 8, 9, 10, and stop. Good morning, everybody. Welcome to Maths with Mr. W. You just joined us at the end of Barry's exercise routine. He's getting good now with his star jumps. Today we're going to be looking at weight, weight, and we're going to be doing something practical, and we're going to be weighing some objects that we find around the house and seeing what the heaviest object is that we can find. So some key words to start with: heavy and light. Okay, if you find something that is weighs more, it's heavier. If we find an object that weighs less, it is lighter. If we find another object which is really heavy, it's probably the heaviest object that we will find. Likewise, opposite, we find an object that is that weighs even less, then it is the lightest object that we find. Okay, so heavy, heavier, heaviest, light, lighter, lightest. Alright, Stripey, I just haven't got the range, I know. I'm going to show you quickly how we can make some balancing scales at home with a few things lying around the house. Right, okay, here's my balancing scales. So I've used an old coat hanger. If you don't have a coat hanger, you could probably use a stick, and somehow you'd have to make a hook, maybe with some string to hook it over the door handle. I've gone with pipe cleaners. You might not have pipe cleaners, especially at this time, so I could recommend using wool. So I've got 1, 2, 3 on each side, and to add stability to the bucket, which I've used 2 drinks bottles. I made holes because I couldn't find my hole punch, so I've used holes very carefully with a sharp pencil and some Play-Doh, and then all I've done is threaded my pipe cleaner through the hole and twisted them on. Okay, so I'm just going to add this third one through the hole, and then I'm ready. So as you can see, I've set up my balancing scales. They're just hooked onto the door handle, and as you can see, they're nice and straight at the moment, which means that they're balanced. Okay, so these are balanced. There's nothing in the buckets, and if you can imagine a helium balloon, those balloons that fly off into the sky, they are very light. So you can imagine they're going up, whereas if something's very heavy, it goes round. Okay, so we always have something we have to remember. So when they're very heavy, things are heavy, they fall to the ground quite quickly. Whereas something's very light, it flows up. And it's the same sort of principle with the when we're balancing. Okay, if something's heavy, it goes down, and then the lighter object will stay up. Okay, let's have a quick look now in the bucket of objects that I found. So let's go with this Happy Mother's Day hand painted rock. Very pretty. I'm going to put it into this balance bucket here. Okay, wow, wow, look at that, that went straight down. And let's compare that with a piece of chalk. Let's have a look what happens. Wow, Stripey, did you see that? What happened? Nothing. He's saying nothing happened. The rock stayed at the bottom. And why is that? Why is that, Stripey? Why would the rock stay at the bottom? Because it is heavier. It's heavier. So the rock is heavier than the chalk. How else can we say that? We swap them round, can't we? We could say the chalk is lighter than the rock. Okay, so we can use both terms, that's absolutely fine. The chalk is lighter than the rock is heavier than the chalk. Okay, so you don't have to do this at home if you don't want to, but it'd be lovely to be able to record it on a piece of paper and pen. And I will just put, okay, when we're doing experiments like this, it's always good to record our results, because we are investigators, and it's nice to remember what we did. So I'm going to take that rock out, and we'll save that at the side, and we'll put the chalk in it. So as you can see, I took both objects out and the balance scales returned to balanced. Okay, let's have a look what we can find here. A potato. Did you put that in there, Stripey? Alright, let's put the potato in. Ooh, okay. Let's have a little rummage around here. Oh, what's this? Ooh. It lights up. How cool is that? Ah, interesting. So which object is the heaviest? That's right, it's the potato. So I'm going to keep the potato in there. I'll take the chameleon out, and I'm going to put that lovely rock back in. Okay, let's have a prediction then. Let's have a think. A prediction. Which object do we think is the heaviest of all? The heaviest object that we've weighed today? Is it the potato or the rock? Let's pop it in. Oh wow, let's just stabilise it. Are they the same? Is that balanced? I didn't mean it to be balanced. How interesting is that? How cool is that? So we can say that's balanced. Wow, I'm going to have to write that down. It doesn't mean to say all potatoes and rocks weigh the same, and that's what you can investigate. Maybe if you've got some potatoes at home, you can have a look and explore the different weight of potatoes and find out which is your heaviest potato and which one is your lightest potato. It's the same with rocks. You will get heavier rocks than that, and you'll get lighter rocks than that. It was just magic that they both were the same weight. So, are big objects always heavier than small objects? Likewise, are small objects always lighter than big objects? Let's have a look. I've got a lovely yummy Oreo Easter egg there, and I've got a larger, it's a slightly bigger plastic ball. Now, you might think that the plastic ball is heavier than the chocolate egg because it's bigger, but let's have a look. So that's the plastic ball, and that's the egg. Okay, and as you can see, although it's smaller, the Easter egg, the little chocolate egg, is actually heavier than the ball. So it's not always about the size of the object, it's about what they call the density, how thick that object is. Okay, I'm really looking forward to seeing your different types of balancing scales that you come up with and some of your results. Let me know what your heaviest object is and what your lightest object is. Good luck, and Stripey, Barry will see you soon.